Assalamualaikum warahmatullahi wabarakatuh. This is example 14, where in this example, I will explain about the effectiveness NTU method. Previously, I'll explain about the Q dot maximum for a system because Q dot maximum will be used in your effectiveness NTU method. It is important for you to understand where does the Q maximum value comes from and why does we choose C minimum as our heat capacity in that equation. Okay, now we focus more on the effectiveness NTU method. Okay, so let's take a look at the question. Okay, a counterflow double pipe. Okay, this is the question. Heat exchanger is to heat water from 20 degrees Celsius to 80 degrees Celsius. Okay. At a rate of 1.2 kilogram per second. So after this, you will see the figure of this question. The heating is to be accomplished by geothermal water available at 160 degrees Celsius at a mass flow rate of 2 kg per second. The inner tube is thin wall and has a diameter of 1.5 centimeter. The overall heat transfer coefficient of the heat exchanger is 640 watt per meter square Kelvin. Using the effectiveness NTU method, that means the length of the heat exchanger required to achieve the desired heating. So let's take a look at the information given in this question. So from here, we already been given the T temperature, so heat water, so the temperature in and temperature out. Water in 20 degrees Celsius, this is T cold in, and then heat up to T C out, so from 20 to 80 degrees Celsius. So the mass flow rate for the cold water has been given, okay, 1.2 kilogram per second. Now, the heating is to be accomplished by geothermal water. This 160 degrees Celsius is TH in for your system and at mass flow rate of 2 kg per second. So for the geothermal water, the temperature outlet was not being given in this question. So therefore, it will remain unknown. The inner tube is thin wall and has a diameter of 1.5 centimeters. So as I mentioned in the previous video, when there is this kinds of statement in your question, you may assume that your conduction process is negligible. Okay, when there is a thin wall statement in your question, the conduction, basically this conduction refers to resistance for the conduction. So what is important of the resistance? Because in order for us to calculate, okay, overall heat transfer coefficient, we must sum up all the resistance in our system. Therefore, since this is a thin wall, therefore the conduction process can be neglected. Okay, has a diameter of 1.5 centimeter. This means that when it is a thin wall, the inlet is equivalent to the outlet. So you must remember this. Okay, so in order for you to calculate the surface area for outlet tube, or you want to calculate what is the area for the inlet tube. Therefore, the I here is equivalent to the out since it is a thin wall. So remember, thin wall represent, there is two things that you must remember when there is a statement about thin wall. First is conduction will be negligible. Therefore, there is no resistance for the conduction. Second is the diameter inlet is equal to diameter outlet. So in this question, the overall heat transfer coefficient of the heat exchanger is already been given. Therefore, you are not necessarily going to calculate what is the overall heat transfer coefficient. So as I explained before, we have 1 over Hi plus 1 over H out. So this is 1 over U. So if you have more, this is your system have only convection outlet and inlet. Okay, outlet and inlet. If you have resistance, so you have to put resistant conduction here. If you have fouling, so you have to include the fouling and so on. Okay. So using effectiveness NTU method. In this question, ask specifically that you will use effectiveness NTU method. What if this question change a little bit and this question asks only determine the length of the heat exchanger required to achieve the desired heating? What kinds of method that you will use in order for you to determine the correct or the suitable method to be used, either it is LMTD or NTU method for this question? If I remove the word using effectiveness NTU method, this question asks you about determine the length of the heat exchanger, for example. So what kinds of method suitable for you to use in order for you to solve this question? So you have to take a look at the temperature. As I mentioned before, temperature, inlet and outlet. So let's take a look at the figure. So this figure is normally are not being given in your question. Therefore, you have to draw it by yourself and then include all the temperatures, inlet and outlet. So this is the geothermal water into the shell and tube, counterflow double pipe heat exchanger, and then this is the outlet temperature, outlet of this geothermal water. So geothermal brine or geothermal water before. So we know that the temperature inlet for the geothermal is 160 degrees Celsius, but the temperature outlet of the geothermal is not being given. Okay. And then what about the cold water? Cold water enters at 1.2 kilogram per second at 20 degrees Celsius and then leaves the system at 80 degrees Celsius. So we have a complete information about the cold water in and out, and then we have the flow rate of the cold water. Whereas for the geothermal water, we are only have info about the flow rate of the geothermal into the shell side, and then 160 degree is for TH in for the geothermal water, and then we are not being given with the TH out for the system. So now, how can we know that which method is suitable for this system? So, as you remember, as you can memorize, as you can refer back to your LMTD method, LMTD required in every of the temperature inlet or outlet, you must have temperature value. Okay, so in this case, we do not have the temperature outlet for the geothermal brine. Therefore, we cannot use LMTD method in this question. Okay, you have to use NTU method. So NTU method, one of the outlet temperature will not be given to you. So therefore, you directly use the NTU method. So now we only the only unknown here is temperature H out. So therefore, you can use the NTU method. Okay. Now, in the NTU method, we have a few questions, a few equations that you must remember. Where the first one, Okay, I wrote down the equation. The first one is effectiveness. So this effectiveness is equal to Q dot actual, okay, divided by the Q dot maximum. So the actual value, the actual rate of heat transfer comes from, so Q dot equal to, let's say QC. So cold water, CC, okay, TC out, outlet temperature for the cold, minus T, cold water inlet. That is the first one. This is QC, heat capacity. Yeah? So the other one is Q dot H, is CH, TH in, minus TH out. So by using these two equations, you are actually calculating the actual value of the rate of heat transfer. So previously, we know that the Q maximum here comes from this equation. Q dot max is equal to C minimum, okay, T H in minus TC in. So this is equation for the Q maximum. So where do we get the C minimum? We have to compare heat capacity for the cold water and heat capacity for the hot water. So both of these equation, you already know about it because previous example is already explained about the CC. So again, I wrote down the equation. For the CC, you will multiply specific heat capacity of the cold water times with mass flow rate of the cold water. So if you are required to calculate what is the rate of heat transfer, therefore this will be mass flow rate. If you are required to calculate the Q only without the per second, therefore this equation will be mass only. Okay, so for the CH, the equation is CP, specific heat capacity, CP H times with M dot H. So by calculating this equation, okay, CC and CH, you will compare both of these value and then find the minimum value between this CC and CH. Then that C minimum will be C minimum in this Q dot maximum equation. So that is the first equation. I think I already wrote down all the equation for the effectiveness NTU method. The other equation will be shown in the table. Oh no, graph and table. Yes, graph and table. Okay. Now we take a look at here. I believe that you already know about this table 11.4 and 11.5. So for this 11.4, I'll explain a little bit more on this table. So in this table, you have to know the value of NTU method. How to know? You can calculate the NTU method by using the information from your question. So NTU method, as you can see here, at the upper level of this table, you may find the equation for the NTU. So NTU equation will be UA S over C minimum. Okay, you already determined C minimum from the previous this one. So you already calculate CC and CH and then you determine the C minimum. That is the C minimum. The same C minimum will be substitute into this equation. And then the overall heat transfer equation coefficient, if in the question is already give you the value of this overall heat transfer coefficient, it's okay. If it is not being given, therefore you have to calculate what is the overall heat transfer coefficient. What about the AS? So AS depends on the diameter. So surface area. AS is a surface area. So what is the surface area that you are required to calculate? And now this in this question already give you the values, the info about the thin wall, and therefore you can calculate what is the AS. So after this, we will see how to calculate the AS. So I will explain about this table. Okay, now we have different types of heat exchanger here. 1, 2, 3, and 4. So we have double pipe. In the double pipe, we have parallel flow and counter flow. So in order for you to refer to this table to understand and to calculate what is the effectiveness, this table, you know the value of NTU, or you can calculate the value of NTU. Then what you want to find in this table is effectiveness. Okay, so this is your aim for this table. So you want to find what is the effectiveness here. Okay, that's why you have to calculate. You have to know the value of NTU in order for you to use this equation, this table, okay, or the equation in this table. Now, another thing that you must know about when you refer to this table is C, small case C. Okay, this C is equal to C minimum over C maximum. Okay, specific heat capacity minimum over specific heat capacity maximum. So again here, if you already compare the value of CC and CH, you will know the value which has the minimum. Okay, and then the other value will be the maximum. Therefore, for example, you calculate the CC, then you get 400, for example, and then you calculate the CH, you will get 500. Therefore, this will be the C minimum, and then this will be the C maximum. Therefore, in order for you to calculate what is the C value to refer to this table, therefore you have to divide C minimum with C maximum. Then you will get the value of C. So in order for you to use this table, you must know the value of C, lowercase c, and the value of NTU. You can calculate, okay? Both of these value can be calculated. Then this table, you want to refer what is the effectiveness of that heat exchanger, okay? Then, for example, in this case, you are deals with the counterflow double pipe heat exchanger. Then you refer to double pipe heat exchanger and then counterflow. So under the counterflow, we have two different types of two different equations where each of these equations represent different for the different C. So we different effectiveness for different C. So for example, the first effectiveness here, so here, this, refer to this, we know that this equation is valid for C which less than 1. Okay, for the C less than 1, you have to refer to this equation. For the C equal to 1, you will directly use this equation. Okay, for the C lower than 1, you will use this equation 1, and for the C equal to 1, you will use number 2. Okay, now we go to the second types of heat exchanger, shell and tube. We have one shell pass, 2 4 tube passes. So it represents epsilon 1, effectiveness 1. So if you have one shell pass, 2 4 tube passes in your question, therefore you directly use this equation. If If you have another types of shell and tube heat exchanger, for example, 2 shell passes, 4 shell passes, or how many shell passes, okay, what this is for 1 shell pass, 2 for tube passes. If you have more than 1 shell passes, for example, in your last tutorial you have 2 shell passes, 2 4 and 4, 8 and so on tube passes. So you will refer to the next. We have this n shell passes, 2n, 4n and tube passes. So if you have 2 shell passes, you will have 2 times with n. So 2 shell passes for no, 1 shell passes, 2 tube passes, 2 shell passes, 8 tube passes, for example. Then you will refer to this equation. Okay, but to refer this equation, as you can see here, we have epsilon 1 here. Therefore, you have to calculate the epsilon 1, number 1, then substitute the value of number 1 into this equation. Okay? Then you can calculate what is the epsilon n. N is n shell passes. Or for example, 2 shell passes, so epsilon 2. Okay? That is how you refer to this shell and tube heat exchanger. So we have cross flow, and then and last one, all heat exchanger with C equal to 0. That is how you refer to the 11.4. But you do not have to worry, because this table is actually the same as this graph. Okay, this table 11.4 is the same as this graph. So what you have to know is the value of NTU here. So we have NTU here, and then the value of C, small case c. So again, the same as this table, you have to know the value of C, and you have to know the value of NTU. And after that, again, this is the same as what you practiced before for the graph for one shell for LMTD method, where you have to interpolate if it is in between, and therefore from that intersection you have to calculate what is the effectiveness. So for example, you have 3, and then you draw a straight line, and then you take a look at C value, small case c, and then if it is in this area, so you have to drag your value up to this, and then find what is the epsilon here, so the effectiveness. So this graph is the same as this, so you do not have to worry if you do not know how to refer to 11.4. You may directly refer to this graph. Okay, this graph again the same as this table, and it has a different types of heat exchanger. So the number 1, so this is number 1. This number 1 is for parallel flow, and then number 2 here is for counter flow. So this is for 1 shell pass, 2, 4, 6 tube passes, and then if you have 2 shell passes and 4, 8, 12 tube passes, you will use number 4. And then if you have cross flow here, and we have both fluid and mixed, so you will refer to this number 5. And then the last one here is number 6 for the fluid mix and the other unmixed. I'm really sorry because this graph has not been explained before, because this is not been explained before in your special topic graph. I forgot to include it into your videos. So this is the videos, and this is the first time you saw this graph. Okay, so the way how you refer to this graph, first you have to know what is the NTU. NTU, you will refer to this from at the x-axis of this graph, you will see the equation for the NTU method, and then that is the first value that you have to know before you refer to this figure. And then the second one is you have to know what is the C, small case C. Okay. Now that is another table 11.5. We have 11.4 where we know the NTU value and we have C value. Then we can refer to the epsilon. So this figure graph is the same as table 11.4, but now for the 11.5, this table, you want to find what is the NTU value. So you do not know what is the NTU value because you do not have value. For example, you do not have the value for U, for example, and you cannot solve the NTU equation. Therefore, what you have to do, you have to refer to 11.5. So in order for you to refer to 11.5, you must know what is the epsilon value. So this effectiveness value, where we can calculate this effectiveness by using Q dot actual divided by the Q dot maximum. So both of these equations can be solved. And then you substitute into this equation, then you will get what is the epsilon. Okay? Because you do not know how to find NTU. You do not have the value for example, always, normally, this table can be used to find area. So you do not have the value for the area. Therefore, if you do not know what is the value for the area, you cannot solve for the NTU. And normally, the question will ask you, what is the area of the heat exchanger? So you will refer to this table in order for you to determine what is the value for the NTU. And after you get the NTU method and then refer to this equation, get what is AS. Rearrange the value, rearrange the equation, and you will get what is the area, surface area of your heat exchanger or of that question heat exchanger. Okay. So in order for you to refer to this table 11.5, we have 4 different types of heat exchanger. Okay, now we go to the double pipe. We have NTU value ln 1 minus epsilon 1 plus C and divide by 1 plus C. So in this table, again, we have to calculate what is the C. So C equal to C minimum divide by C maximum. Sorry, this capital letter C. Okay, C minimum divide by C maximum. Okay, so and then you take a look at the types of heat exchanger. For example, your question is double pipe and then counter flow. So for the counter flow, we have 2 different types of equation. Again, first one is for C below than 1, and then the second one is C equal to 1. So please select the right equation for the right question. Okay. And then again for this one, okay, you have 2 different equations, shell and tube. It is the same as before. For 1 shell pass to 4 tube passes, you will use this equation, number 1. And then for the 2 shell passes, 4 tube passes, okay, you will use this equation. So in this equation, we have n value. N value represent the n shell. So if you have 2 shell passes, then you will put 2 value here. And then we have NTU1. Okay, NTU1. So NTU1, you will refer to this value, number 1. Okay. So to find effectiveness of the heat exchanger with 1 shell pass, use epsilon 1 equal to F minus 1 over F minus C. Okay. So in this equation, take a look at this equation. We have epsilon 1 here. So to get what is the epsilon 1, you have to substitute into this equation. So the process is you have to calculate this number 1 and then jump to this if you have 1 shell pass. Okay, 1 shell pass, 2 4 tube passes, then stop. If you have 2 shell passes, 2 and 4 and tube passes, then your step will be 1, okay, to 2, and then this is 3. And then you will go to 3. Okay, you have 3 steps for n shell passes, 2 and 4 and tube passes. Okay, 1 to 2 and then 2 to 3. Okay, so for 1 shell passes, you have 2 steps, 1 and then go to 2. Okay, 3 is cross flow, single phase, a single pass. So you have to take a look at the types of cross flow lah. Okay, mix and unmix, mix and unmix. Okay, depends on the C maximum and C minimum value. So that is how we refer to this to the graph and the tables for the NTU method. Now we go to this question. It takes a little bit longer because this explanation is crucial in order for you to understand how to use the table and how to use the graph. Okay, now we go to this question. So we have a counter flow double pipe, and then we have T inlet, T inlet for both hot and cold, and then we have only one outlet for cold water, which is a temperature outlet for the cold water, which is 80 degrees Celsius. And then the mass flow rate for both liquid has been given, for the cold and hot fluid has been given in this question. Therefore, we take a look at how to calculate the length of the heat exchanger. So from here, we know that when we have to determine the length of the heat exchanger, we are required area. So I think this question will ask you to find what is the NTU value. Okay. So now the first method of NTU method, okay, is to find what is CH and what is CC. Okay, you have to calculate specific heat capacity for the cold water and specific heat capacity for the hot water. So we have M dot HCP H, and then this is M dot cold CP cold, and then we substitute the value. So we have 2 kilogram per second times with 4.31 kilojoule per kilogram dot Kelvin. Okay, and then we will get this value is around 8.62 kilowatt per Kelvin. So second one is mass flow rate for the cold water is 1.2 times with 4.18 kilojoule per kilogram dot Kelvin. So please beware of the kilo, this unit. If you are using watt only, you want to execute this value and then return it as a watt. Therefore, you have to change the kilo into 10 times 10 to the power of 3. If you want to remain here like this, so your value here would have kilowatt. Then this value is around 5.02 kilowatt per Kelvin. Okay, you have these two values. So now the second step is to determine which of these value heat capacity has the minimum value. Either it is CH or CC. So from this value, we know that CC has the minimum value compared to CH. Therefore, C minimum is equal to CC where the value is 5.02 kilowatt per Kelvin. Okay, now we have to find what is the Q maximum. So from the C minimum value. C minimum is TC times with T H in minus T cold in. Okay, the CC value is 5.02 times with 160 minus 20, so degree Celsius. So you will get the Q maximum is around 702.8 kilowatt. So that is your value for the Q maximum from the C minimum. Okay. Now we have to determine what is the effectiveness of this table because of this question. Can we get the NTU? Can we get the effectiveness? Because one, you know that effectiveness can be calculated from table 11.4 or this graph. Okay, to know about the effectiveness, you have to know the value of NTU and C. Okay, C can be calculated because we already calculated it, and we have C minimum and C maximum. What about NTU method? NTU required you to find overall heat transfer coefficient, area, surface area, and C minimum. Of course, you cannot calculate the surface area. Since you cannot calculate the surface area, therefore, table 11.4 cannot be executed. Or you cannot use figure 11.27 to find what is the effectiveness. So, how to calculate effectiveness? Wait, we have another equation for the effectiveness where the effectiveness is Q dot actual over Q dot maximum. So we can actually know what is the effectiveness. And then previously we do not know how to calculate NTU because we do not have enough information. And if we can refer to the question asks about the length, and of course area cannot be calculated. What we have to do is we have to refer to table 11.5 in order for us to get what is the value for the NTU method, for the NTU. So now we are required to find what is the effectiveness here. So the effectiveness is Q dot actual over Q dot maximum. So Q dot actual can be calculated from two different equations. So we have Q dot C, where we have CC times with TC out minus TC in. And another equation is Q dot H, where we will use CH, TH in minus TH out. So we have these two equations to calculate what is the actual. So let's take a look at this figure. Which of the outlet temperature is not been given in the question? So geothermal water. So geothermal water is hot fluid. Okay, QH. So we cannot actually determine, or we cannot find the actual Q dot actual for the hot side. And the complete information that we can actually calculate the Q actual comes from the cold water, because we know the inlet temperature is 20 and the outlet temperature is 80 with the mass flow rate of 1.2 kilogram per second. Now, in this equation, okay, we cannot use Q dot H because do not have enough information, because TH out is not being given in your question. Therefore, the only complete information given in your question is Q dot cold. So we will use Q dot cold to determine what is the value of rate of heat transfer actual. So QC is equivalent to Q dot heat, okay? Because Q is constant. So I give a subscript to differentiate between cold and hot water. Actually, it has the same value, okay? So for the Q dot, so we will use M dot CPC, okay, TC out minus TC in. Please do not confuse with this equation. So CC is CP C times with M dot C. So that's why it becomes like this. Okay, so Q dot equal to M dot is 1.2 times with CP, C is 4.18, okay, kilojoule, kilojoule, and then 80 minus 20 degrees Celsius. So you will get the value for the Q dot is equal to 301.0 kilowatt. So this is the actual rate of heat transfer for the cold water, okay? Which means that the cold water receive the amount of 301 kilowatt energy from the hot water. So that's why hot water will have the same Q dot value, okay? And then after we know this Q dot is Q dot actual. So from here, we can actually calculate what is the epsilon effectiveness, okay? Q actual divided by Q dot maximum. So from here, we know that the Q dot actual is 301 kilowatt divided by 702.8 kilowatt equal to, we get the value of 0.428. Okay? So please make sure that if here is kilo, then your maximum must be in kilo. If you afraid that you will do a mistake, and then I prefer you to convert all the units here, all the units in your calculation into watt only. Okay, I show you in this calculation because it is much more simplified. I want to simplify my calculation. Okay, so you have to convert into watt. Okay, remove the kilo here. Now we already have epsilon. In order for you to refer to this table 11.5 to find what is the AS, so you must know other value where the value for C, small case C. For small case C is C minimum over C maximum. So we already know about the epsilon, and then we calculate the C. Small case C is equal to C minimum over C maximum. So your C minimum, okay, now here you have to, you already determined that CC is a C minimum, then this will be your C maximum. Please take a look at my cursor, this pen. Okay, 8.62 will be your maximum C. So your C minimum is, small case C is 5.02 divide by 8.62. You will get the value of C, small case C is 0.582. Okay, we already have two value for these two value, epsilon and C, effectiveness and C. Then we refer to this table. Okay, from this table, our question is double pipe and then counter flow. So our C value, under the counter flow, we have two different equations. So we have to compare with the C value. So our C value is 0.582. So C is below than 1. Therefore, we will use this equation. So take out this equation and substitute all the values into this equation. Okay. So please take this equation, write down in your notes, pause this video, take into your note, okay, write down this into your in a paper, okay, and then we go to this NTU calculation. So you substitute all the values, you will get the value for the NTU is 0.651. Okay, that is your NTU. Now, we are required to find what is the area. Okay, so we know that the NTU equation is U, overall heat transfer coefficient, times with the AS over C minimum. Okay, we have this equation. So rearrange the equation. AS equal to NTU times with C minimum divided by U. Okay, so you already know NTU method, C minimum you already know. Overall heat transfer coefficient is already been given in your question. So substitute all the values, you will get the area. AS is equal to 5.11 meter square. Okay, you already know about the area. Now we go to find what is the length. So surface area is pi dl. So rearrange this equation, find what is the L. L is AS divided by pi d. So we know that this is thin wall and then diameter is the same in and out. Okay. So L equal to your A is 5.11 okay, meter square divided by pi times with 0.015 meter. So you will get the length of your heat exchanger is 108 meter. Okay. Okay, actually, you can use the LMTD method if you notice that from here, we know that the Q actual for the both cold and hot water is the same. Now you already calculate the Q actual, you get 301.0 kilowatt. So from here, you can equate with the Q dot hot, where you can find what is the TH out here. So from there, you can see that all the temperature is enough, or all the temperature has been we have all the temperatures in our heat exchanger problems, so we can use delta T log mean in order for you to determine what is the area AS. And it depends on this is the easiest because we use a counter flow, and it is not suitable. It is the easiest way lah, okay, to calculate by using the LMTD method. So this method, this problem can use LMTD method, but after all, it depends on the question. If the question specifically asks you to find what is to find by using a specific method, For example, in this problem, specifically asks you to use the effectiveness NTU method, then you have no option. If the question asks you only determine the length of the heat exchanger, then you can choose either you want to use LMTD method or NTU method. Okay, that's all from me for this example, and then thank you.